let us go through this. I said we want to derive the equivalent circuit of this, and we have to do it somewhat systematically. First of all, I have been saying that we do not operate this ever in open loop, right, because it is a high gain circuit, we have to operate it in feedback just like a CMOS inverter or an op amp. But and that is because this symmetry, like for instance M1 exactly being identical to M2 and M3 being exactly identical to M4, this will never happen, there will be small deviations. Okay. But before we get to all of that negative feedback loop and so on, so let us say I bias it like this, the gates of M1 and M2 are connected to VICM, the same voltage, and it is in open loop, it is like this, and let us assume that the transistors are exactly matched. Okay. What will be the voltage here? Imagine that M1 and M2 are exactly matched. So, if so that means that for identical operating points they will have the same GM and GDS and so on, and similarly M3 and M4 will have same GM and GDS and all this. Okay. Okay. What will this be? You have to use the fact that the circuit is perfectly symmetrical. Okay. How would you decide? So, let us say the circuit were like this. Okay. I have only M1, M2 and M3. Okay. So, in this case, what would be this voltage? What would be the current in M1 and M2? I naught by 2. Is that correct? Okay. So, what is that voltage at the drain of M3 or drain of M1? Yeah, what is that? What is that voltage? How would you calculate it? What is that? Yeah, you have to be a little louder. What? Is that voltage or is it the VGS of? What is the VGS of M3 or VSG of M3? What is that? Whatever is required to support a current of I naught by 2. How much is that? The VSG has to be VTP plus square root I naught by Kp. Okay, assuming I naught by 2 flows here, I naught by 2 flows there. So, this voltage is VDD minus that voltage. Okay. So, in this case it is very easy to calculate the voltages, right, because if you know that I naught by 2 is flowing, essentially what we have is a small incremental resistance connected to the drains, it is very easy. But what is it in this case? Now, we know the voltage here, what will it be in this case? How will you reason it out? What is this voltage? What is that voltage? It will be the same. Why? Okay, but why do you say that? Yeah, I understand. The voltage here is what we calculated, VDD minus VTP minus square root I naught by Kp. Why is the voltage here exactly the same as that? Yeah, okay. VSG of both are the same. Yeah. This is this voltage here is unrelated to any VSG as far as I can tell. Huh? Lambda is not 0. If lambda is 0, then you will have an ambiguity. Lambda is of course same for M1 and M2 and also M1 and M2 are the same as each other, M3 and M4 are the same as each other. There is no relationship between M1 and M3. How do you know currents are equal? How do you know currents are equal? Yeah, but lambda is not 0, right? You could see the drain current of a MOS transistor is primarily determined by VGS, okay, but it is also influenced by VDS. So, it is possible for two transistors to have the same VGS, but different VDS and have slightly different currents. So, how do I know that the currents are not slightly different from I naught by 2 and I naught by 2? Yeah, okay, I don't know if it forces, but you do that. Assume that the voltages are different and see if that is possible or not. Okay. So, let us say we call this VD1 and this is VD2 and assume that VD1 you can calculate if you know how much current is flowing, but let us say VD1 is not equal to VD2, what happens then? Is that an acceptable solution or not? So, let us assume that VD1 is greater than VD2. What does this mean? M1 and M2 have the same source voltage. So, VDS1 is greater than VDS2, which implies that the drain current in M1 is more than the drain current in M2. Okay. But this is not the only matched pair, M3 and M4 are also matched, they have the same VSG. So, their drain current, any difference is decided only by the difference in VSD. Okay. Now, this thing means that VSD3 is smaller than VSD4, right, because this we said that VD1 is more than VD2. So, this voltage is bigger than that voltage. Okay. Now, what does that say for drain currents of M3 and M4? This means that ID3 is less than ID4, but ID1 is the same as ID3, ID2 is the same as ID4. So, you can't have this, right. So, if they are perfectly matched even in open loop, equal currents will be flowing through the transistors, and what will be the output voltage? What will be the voltage here? Same, VDD minus VTP minus square root I naught by Kp, basically VDD minus VSG3. Which one? Oh, I didn't bother to calculate this. Actually, if I had connected, maybe I should have shown this circuit, which by symmetry would also have equal VDS as well. But actually, the way I drew it, if I do that, the currents will be slightly different. Okay. So, the current here will be slightly more than the current there, but the point I was trying to make was something different. Once you know this current, you can find this voltage, whereas in this particular case, it is not, you can't find this voltage by I mean very easily. You have to invoke the symmetry argument to say that this will be the same as the other side. Okay. This is okay? Where? In this case. So, again I am assuming non-zero values of lambda, right. So, what is VDS2 compared to VDS1? Be more or less or the same? VDS2 compared to VDS1. More. Why? Obviously, there will be some voltage here, whatever that voltage is, right. So, the voltage here will be more than the voltage there. So, that is all. Now, VGS is the same, VDS is larger. So, the current will be slightly more. But here what happens is, even if you ignore the difference and calculated this voltage, you would not make a very big error, okay, because the current is slightly different because of this lambda effect, but that will cause a small difference in voltage, okay. Whereas in this case, I mean, you can't calculate it at all, right. Is this okay? So, this is an important thing, that if the structure is perfectly symmetrical, although there is no feedback, this voltage will be the same as that voltage. Again, keep in mind that this is just a hypothetical thing where we are assuming perfect symmetry. This will never happen in practice, and in practice you have to use negative feedback around the whole structure. Okay. Yeah. Why? Drain and gate of M3. Oh, what will be the gate voltage in this case? It is not even set, right? It is only because of feedback that you can set it. So, both these voltages in quiescent condition, okay.